One very important application of electrochemistry or electrolytic cell is to change impure metals to pure metals, and we call it as electrorefining. Impure metals, suppose copper 96%. This 96% copper is obtained by chemical reduction of copper ores. That's not an expensive process, and copper 96% is obtained. It has 96% copper, but rest is mainly gold and silver, a sort of alloy. And this copper may be good for making cooking utensils or pipes or whatever. Okay, may be good, but this copper cannot be good for making electrical systems where it is used as in cables. The reason behind is when impurities are there, they will offer a resistance to the flow of electrons. Lattice is not that fine, so electrical conductivity may not be that good. It's not good rather, and in that case heat is created, resistance to the electron is given, and that heat create normally goes to the electric fires, which are most common these days because of impure copper usage. So impure copper can be changed to pure copper. Now the interesting thing it is, if it is a sort of impure copper block, 96% it has atoms of gold and silver in it. Now it's not an easy task to turn it into pure one because you melt, everything is melted. Atom is so small, a full stop contains trillions. You cannot pick them off like any grains. But chemists have devised a wonderful method, and that wonderful method is of course the electrolysis based. In the electrolytic cell, this impure copper anode, the huge beam of impure copper anode, is clutched with, using the clutches, it is clutched with what? The positive cable. The positive cable mean with the positive terminal of the battery. So with the positive terminal of the battery, when this anode is connected, it acquires the status of what? It acquires the status of anode. With the negative terminal of the battery, the negative cable, a little thing is clutched, already prepared somehow, pure copper strip. And the electrolyte is of copper sulfate aqueous solution, which contain copper ions and sulfate ions. No doubt hydrogen ion, hydroxyl ion. But when we switch on the power and you leave it for hours, depending on the voltage you use, you will be stunned at the next visual. And that visual is what? The anode has shrunk to the minimum of size. Shrunk to the minimum of size. There is an impurity sludge beneath it. We call it as anode sludge. It contains copper and silver. And the cathode, which was of a very small size, has gone to a maximum of size. Difficult for clutches to hold it. So you have an asset of what? Pure copper now. And impurity is staying behind. Anode has gone to a minimum of size and cathode has gone to a maximum of size. You need to switch off and replace the whole process there. Drag another impure anode, clutch it to the place, impure beam of copper, clutch it to the anode, and pure strip again taken off, and the visual is set like this, and wait for hours again. Now what is the chemistry behind this? The chemistry behind this is basically at anode, copper atoms are turning into the solution as copper ions. As usual, anode dissolves copper atoms to copper ions, leaving behind their electrons. Electron need a medium, they stays back. But the solution has copper ions in plenty. You know the copper ions are positive ion. They are lower in the reactivity series, even lower than the hydrogen. So they can't stay there. They will rush to the negative terminal. Rather, cathode is definitely grabbing them to itself, being negative terminal, being a negative electrode potential. So copper ions rush to the cathode, and cathode is rich with what? Electrons, and they accept the electron there and turn to what? Copper atom, and that atom is deposited at its surface. So it means ultimately atoms are turning to ions and ions are turning to atoms. Atom to ion, ion to atom, atom to ion, ion to atom. So it means by this process you basically have picked up each atom and turn it into iron, and iron again turn to atoms. As cathode is rich in electron, these electrons are reaching there as well. So we find out that copper atoms are turning to copper ions, leaving the electron behind from the anode. That is why the mass of anode is seen what? Decrease. If the examiner asks you that what actually is seen at the anode, we see anode dissolves. Anode basically decrease in mass, and reason behind anode, atoms are turning to ions, and ions cannot stay there as cathode is heavily charged, negative charge, high voltage. Ions go there and get discharged. So atoms to ion and ion to atom. I mean, they go and out they come. So the next visual suggests what? Almost all the atoms have turned to ions, and ions have gone back to turn into atom. So cathode has gained in mass. We have a huge asset of pure copper, use it for electrical wiring and gadgets and all that, and anode has shrunk to the minimum size. Since the process has gone slow, switch off and replace with everything new again in the same fashion. So special kind of electrolysis it is. Sometimes when we use this as an example, we ask the question like this: electro refining of copper, or impure metal to pure metal, or question can be like this: show electrolysis of copper sulfate aqueous using copper electrodes. When this is asked using copper electrodes, this is not the case of inert electrodes then anymore. It means examiner wants you to basically explain the process of electro refining. When he says aqueous copper sulfate using copper electrodes, it means that is electro refining. It is not basically the inert electrodes process, because if it is carbon and carbon here as anodes and cathode, you will find out that usual electrolysis like hydroxyl will discharge at anode and bubbles of a colorless gas, and copper ions, they need to discharge because they are lower in the reactivity series, even lower than the hydrogen, so they will discharge at the cathode. But after some time the blue color will fade. It means copper ions are exhausted. But industry will not carry out that, rather industry will carry out the electrolysis of copper sulfate using copper electrode, because that's a mechanism used for the production of pure copper. And in that case, huge beam of copper is linked with a positive terminal which acts as anode, and it dissolves into ions. Look at that, the equation shows copper atom to copper ions leaving the electron behind. These ions cannot stay there, they'll accept electron turn to copper atom. So story is what? Atom to ion, ion to atom, atom to ion, ion to atom, atom to ion, ion to atom. They keep on depositing there. Mass of the cathode increases, mass of the anode decreases. That's what we want. We need to run away with what? Almost 100% copper. So that is the method basically for an impure metal to turn to pure. Any example you can take, the metal which is impure, the metal X, has to be placed at the anode, and the pure strip of that metal at the cathode, and electrolyte of the same metal, salt, okay, same metal, electrolyte, salt as an electrolyte. You switch on and you will find out the same thing, that after some time your pure cathode will increase much in size, and your impure anode will shrink to the minimum of size with a load of impurities beneath. So that is how impure metals are turned to pure metals, especially copper. Okay, so electrolysis of or electro refining of impure to pure metals, we call it is electro refining. And this is, in this case, 96% copper has gone to what? Almost 100%. You need to memorize these, understand these observations and reactions at the anode, that anode dissolves and cathode gains in mass, because anodic oxidation, loss of electron, and cathodic reduction, gain of electron. That is electro refining of copper, or electro refining for any metal to turn it from impure form to pure form. जी इलेक्ट्रो रिफाइनिंग आ रही थी.